Hi everyone, Zach here, and welcome to the prep video for lesson 23 in this series on developing a survival game. In this video, we will discuss IES lighting profiles. In the tutorial itself, we will create a lighting system. To do so, we will import a lighting profile. We will create a flashlight system with a battery system that uses a timer. Based on our battery level, we will have a flicker effect or turn the flashlight off. So let's take a closer look at that aspect of our system. So the way the system will work is that we will have an input event that sets the light and a boolean and sets a timer. So if we're turning on the light, we will set the light to be active, we'll set the boolean to be true, and we will check, did a timer already exist? Or do we need to create a timer? We are going to use our timers in a more performant fashion. The timers will be our battery event, which reduces our battery level, and it checks that level, depending on what level it's at. So if it's under 15% but greater than 0, we will have a flicker. This will be our warning to our player that, hey, the battery is dying. At 0, it turns off the light, and which means that it does the reverse of the input event, and it stops the timers. So, what is a lighting profile? A lighting profile is a texture gradient, though, that said, even Epic says this is not an actual texture. That is a standardized form of diagramming the brightness and fall off of a light, as if that light existed in real life. And doing so, it can account for, say, even the reflective surfaces of a lighting fixture. So if you have a highly, shiny, reflective interior to a hanging lamp, this lighting profile can account for that reflective surface inside of the hanging fixture. Now, it uses a gradient curve to show the brightness and fall off of the lighting. And again, this is useful for simulating real-life lighting conditions. Now, you might think, oh, this isn't going to be really performant. According to Epic, IES profiles render very fast and do not have significant effect on performance, making them a more ideal option for shaping your lighting than a light function. So in other words, this is the more performant option when it comes to lighting. Now, it is important to note a couple of things. First, when using an IES profile on a point or rect light, it makes them visually akin to a spotlight. All the other features of a point or rect light are still there, but visually speaking, they become the same as a spotlight. And it's important to note with spotlights that the maximum extent of a cone is 179 degrees. Meaning that if an IES lighting profile has data outside 170 degrees, that the spotlight will ignore that data. That said, this series has been brought to you by Patreon sponsors like Rian, Quadmenson, Hanas, and 1Vault10. I look forward to seeing you in the main tutorial and hope that you have a wonderful day.